All right, so we are now in Module 11, Network Design. In this module, we're going to cover the module objective, explain the characteristic of scalable network architectures, such as hierarchical networks, scalable networks, switch hardware, and router hardware. In hierarchical networks, we're going to explain how data, voice, and video are converged in a switch network. And under scalable networks, we're going to explain the considerations for designing scalable network. And under switch hardware, we're going to explain how switch hardware features support network requirements. And last is the router hardware. We're going to describe the types of routers available for a small to medium size business network. Hierarchical network. Our digital world now is changing, and the ability to access the internet and the corporate network is no longer confined with physical offices, geographical locations, or time zones. In today's globalized workplace, employees can access resources from anywhere in the world, and information must be available at any time and any device. These requirements drive the need to build next-generation networks that are secure, reliable, and highly available. The next-generation network must not only support current expectations and equipment, but must also be able to integrate legacy platforms. Businesses increasingly rely on their network infrastructure to provide mission-critical services. As business grow and evolve, they hire more employees, open branch offices, and expand into global markets. These changes directly affects the requirements of a network, which must be able to scale to meet the needs of business. The network must support the exchange of various types of network traffic, including data files, email, IP telephony, and video applications for multiple business units. All enterprise networks must be able to do the following. It must support critical applications, support converged network traffics, support diverse business needs, and provide centralized administrative control. The LAN is the networking infrastructure that provides access to the network communication services and resources for end users and devices. The end users and devices may be spread over a single floor or building. You create a campus network by interconnecting a group of plants that are spread over a small geographic area. Campus design includes small networks that use single LAN switch up to very large networks with thousands of connections. Now, what is borderless switch networks? With increasing demands of the converged network, the network must be developed with architectural approach that embeds intelligence, simplifies operations, and is scalable to meet the future demands. One of the more recent development in the network design is the Cisco Borderless network. The Cisco Borderless network is a network architecture that combines innovation and design. It allows organized to support organization to support a borderless network that can connect anyone, anywhere, anytime, or any device securely, reliably, and seamlessly. This architecture is designed to address IT and business challenges such as supporting the converged network and changing work patterns. The Cisco Borderless Network provides the framework to unify wired and wireless access, including policy, access control, and performance management across many different device types. Using this architecture, the borderless network, as you can see in the figure, is built on a hierarchical infrastructure of hardware that is scalable and resilient. By combining this hardware infrastructure with policy-based software solutions, the Cisco Borderless Network provides two primary set of services: network services and user and endpoint services under the umbrella of an integrated management solution. It enables different network elements to work together and allows users to access resources from any place at any time while providing optimization, scalability, and security. The hierarchy in the borderless switch network. Creating a borderless switch network requires that sound network design principles are used to ensure maximum availability, flexibility, security, and manageability. The borderless switch network must deliver on current requirements and future required services and technologies. Borderless switch network design guidelines are built upon the following principle. Hierarchical, modularity, resiliency, and flexibility. Those are the principles governing the hierarchy of the borderless switch network. Hierarchical in nature, modular in nature, resilient, and flexible. And these are not the borderless switch network is not independent principle. Understanding each principle fits in the context of the others is critical. Designing a borderless switch network is hierarchical fashion creates a foundation that allows network designer to overlay security, mobility, and unified communication features. The three critical layers within this tiered designs are access layer, distribution, and core layers. Each layer can be seen as well-defined structured module with specific roles and functions in the campus network. Introducing modularity into the campus hierarchical design further ensures that the campus network remains resilient and flexible enough to provide critical network services. So in this figure, you can see an example of three-tier campus network and two-tier campus network. The two-tier campus network used by organizations requiring access, distribution, and core layers. This is usually the setup on a three-tier campus network. The recommendation is to build an extended star physical network topology from a centralized building location to all other buildings on the same campus. So if your campus is large enough with several remote locations within the area, the recommended design is three-tier campus network, wherein the building A management place the core, where core will be placed under the building management, and then the distribution, next is the distribution, and last is the access layer. While in the two-tier campus network design, this is used when separate distribution and core layers is not required. This is useful for smaller campus locations or in campus sites consisting of a single building. This is also known as the collapsed core network design. So if you have a single network, two-tier campus network is recommended. This is also called the collapsed core design, core network design, wherein one router is connected to the internet, and next is the multi-layer switch, and then from the multi-layer switch goes to the access switch, the access layer, where all the users are connected. So these are the example of the tier design. Now, what is the role of switch network? Networks have fundamentally changed from a flat network of hubs to switch LAN in hierarchical network. The old design of network is using hubs, and this is no longer recommended as a connection for the current converged network. Because in the converged networks, there are three traffics that has to be maintained. It has to be maintained the quality of service of the three traffic that is flowing in the network: the voice, data, and the video. As you notice, this is a switch network. It involves the multi-layer switch, the router, and then the access switch. A switch LAN allows additional flexibility and traffic management, quality of service, and security. A switch LAN may also support wireless networking and other technologies such as IP phone or IP telephone and mobility services. The role of switch network also follows the hierarchical design from the core. Next is the distribution layer, and then the access layer. Switch is also important nowadays because it provides, you can create a redundancy to avoid the failure. Hierarchical design should be highly available and scalable. So scalable, if your network design, if you would like your network design to be scalable, Cisco recommended the use of switch. So what is a scalable network? Scalability is the term for a network that can grow without losing availability and reliability. Your network is scalable if, upon expansion of the network, you can still provide the services to the end users. Availability is still maintained and the reliability of the network is there. That is scalability. Network designer must also develop strategies to enable the network to be available to scale effectively and easily. And this is accomplished using redundancy, multiple links, scalable routing protocol, wireless connectivity. You have to understand that your network is going to change. Its number of users will likely increase. They may be found anywhere and they will be using a wide variety of devices. Your network must be able to change along with its users. So that's why your network should be scalable. To support a large, medium, and small network, the network designer must develop a strategy to enable the network to be available and to scale effectively and easily. Included in the basic network design strategies are the following recommendations. Number one recommendations is use expandable, modular equipment or cluster devices that can easily be or that can be easily upgraded to increase capabilities. Device modules can be added to the existing equipment to support new features and devices without requiring major equipment upgrades. Some devices can be integrated in a cluster to act as one device to simplify management and configuration. So the design of hierarchical network to include modules that can be added, upgraded, and modified as necessary without affecting the design of the other functional areas of the network. For example, creating a separate access layer that can be expanded without affecting the distribution and core layers of the campus network. For the advanced network design, redundant link is very important. You need to implement a redundant link in the network between critical devices and between access layer and core layer devices. Another one is multiple link. Multiple link implement multiple links between equipment with either link aggregation or ether channel or equal cost load balancing to increase the bandwidth. And combining multiple Ethernet link into a single load balance ether channel configuration increases the available bandwidth. Ether channel implementations can be used when budget restrictions prohibit purchasing high-speed interfaces and fiber runs. So another consideration for the modern design is scalable routing protocol. You need to use the scalable routing protocol and implement features within that routing protocol to isolate routing updates and minimize the size of the routing table. And another factor to consider in a modern network design is the wireless connectivity. You need to implement wireless connectivity to allow more mobility and expansion. Next up is the plan for redundancy. For many organizations, the availability of the network is essential to supporting business needs. Redundancy is an important part of the network design. It can prevent disruption of network services by minimizing the possibility of single point of failure. One method of implementing redundancy is by installing duplicate equipment and providing failover services for critical devices. As you can see in the figure, redundant link between important devices on a network. In the wire closet, in the wiring closet, there are two switches, and in the backbone there are four switches. The six switches are redundant link. The backbone switches also have redundant link to the server farm. The server farm consists of two switches and 7 servers. Another method of implementing redundancy is redundant path. As you can see in the figure above, redundant path offers alternate physical path of data to traverse the network. Redundant paths is a switch network support high availability. However, due to the operation of switches, redundant paths in a switch Ethernet network may cause logical layer 2 loops. For this reason, spanning tree protocol is required, because STP eliminates layer 2 loops when redundant links are used between switches. It does this by providing mechanism of disabling redundant paths in switch network until the path is necessary, such as when failure occurs. STP is an open standard protocol used in switch environment to create a loop-free logical topology. Now, to reduce the failure domain size, a well-designed network not only controls traffic but also limits the size of failure domains. A failure domain is the area of the network that is impacted when critical device or network service experiences a problem. The function of the device that initially fails determines the impact of the failure domain. For example, a malfunctioning switch on a network segment normally affects only the host on that segment. However, if the router that connects the segments to the other fails, the impact is much greater. So the use of redundant link and reliable enterprise class equipment minimizes the chance of disruption in a network. Smaller failure domains reduce the impact of a failure on a company productivity. They also simplify the troubleshooting process, thereby shortening the downtime for all users. So to increase the bandwidth, in hierarchical network design, some link between access and distribution switches may need to process a greater amount of traffic than other links. As traffic from multiple links converges into a single outgoing link, it is possible for that link to become a bottleneck. So links aggregation such as Ether channel allows an administrator to increase the amount of bandwidth between devices by creating one logical link made up of several physical links. Ether channel uses the existing switch port, therefore additional cost for upgrade. To upgrade the link to a faster and more expensive connections are not necessary. The Ether channel is seen as logical link using the Ether channel interface. Most configuration tasks are done on the Ether channel interface instead on each individual port, ensuring configuration consistency throughout the link. And the Ether channel configuration takes an advantage of load balancing between links that are part of the same Ether channel. And depending on the hardware platform, one or more load balancing methods can be implemented. Expanding the access layer. The network must be designed to be able to expand network access to individuals and devices as needed. An increasingly important option for extending access layer connectivity is through wireless. So that is one of the options. Providing wireless connectivity offers many advantages as increased flexibility, reduced cost, and the ability to grow and adapt the changing network and business requirements. So to communicate wirelessly, end devices require a wireless network interface card or NIC that incorporates a radio transmitter receiver and the required software driver to make it operational. Additionally, a wireless router or wireless access point is required for users to connect, as you can see in the figure. There are many considerations when implementing a wireless network, such as the type of wireless device to use, wireless coverage requirement, interference considerations, and security considerations. Tune routing protocol. Advanced routing protocols such as Open Shortest Path First or OSPF are used in the large network. OSPF is a link state routing protocol. As you can see in the figure, OSPF works well for larger hierarchical network where fast convergence is important. OSPF router establish and maintain neighbor adjacency with other connected OSPF routers. OSPF synchronize their link state database. When a network changes occurs, link state updates are sent informing other OSPF routers of the change and establishing a new best path if one is available. So the figure illustrates the use of using routing protocols in large networks. As you can see in the figure, there are a variety of switch platforms. You can see in the figure, Area 1, Area 0, and Area 51. Area 1 has 4 routers with one labeled R1 as the edge. R1 is in both Area 1 and Area 0. Area 0 has 2 routers, R1 and R2. And R2 is both Area 0 and Area 51. Area 51 consists of 4 routers connected via serial link. Okay, let's move on with the switch hardware. One simple way to create hierarchical and scalable network is to use the right equipment. The right equipment for the job. There is a variety of switch platform, form factors, and other features that you should consider before choosing a switch. When designing a network, it is important to select the proper hardware to meet the current network requirements as well as to allow the network growth. Within an enterprise network, both switches and routers play a critical role in network communication. Switches can be categorized as campus LAN switch. To scale network performance in an enterprise LAN, there are core, distribution, and access and compact switches. So these are examples of switch platform. There is a Cisco Meraki Cloud Managed Access Switch. There are also Cisco Nexus platform promotes infrastructure scalability. So this example of switches are used for enterprise network. For service provider Ethernet access switches, These are the example of the switches used in the ISP. And the switch form factors, when selecting a switches, network administrator must determine the switch form factors. This includes the fixed configuration, modular configuration, stackable or non-stackable switches. These are the switch form factors that has to be considered by a network administrator. There is also special cables are used to connect stackable switches that allow them to effectively operate as one large switch. So the thickness of the switch, which is expressed in the number of racks units, is also important for switches that are mounted in a rack. The port density of a switch refers to the number of ports available on a single switch. So the figure shows the port density of three different switches. So there are fixed configuration switches supports variety of ports density. The Cisco Catalyst 3850 comes in 12, 24, 48 port configuration. And the modular switches can support very high port densities through the addition of multiple switch port line cards. The modular Catalyst 9400 switches supports 384 switch port interfaces. So these are the port density, the number of ports available. The forwarding rates defines the processing capabilities of a switch by rating how much data the switch can process per second. Switch product lines are classified by forwarding rates. Entry-level switches have lower forwarding rates than enterprise-level switch. Forwarding rates are important to consider when selecting a switch. If the switch forwarding rate is too low, it cannot accommodate full wire speed communication across all of its switch ports. So wire speed is the data rate that each Ethernet port on the switch is capable of attaining. Data rates can be 100 Mbps, 1 gigabit per second, 10 gigabit per second, or 100 gigabit per seconds. These are the forwarding rates. Large network that support many thousands of network devices requires high density modular ports. The power over Ethernet allows the switch to deliver power to a device over existing Ethernet cabling. These features can be used by IP phones and wireless access points. No need to have a separate adapter to power up the switch, because this power over Ethernet has an embedded power in the cable. A network administrator should ensure that the PoE features are actually required for a given installation, because switches that supports PoE are expensive. For example, a typical 48 gigabit switch operating at full wire speed generates 48 Gbps of traffic. If the switch only supports a forwarding rate of 32 gigabit per second, it cannot run at full wire speed across all ports simultaneously. Okay, the multi-layer switches. Multi-layer switches are typically deployed in the core and distribution layers of organization switch network. A multi-layer switch are characterized by their ability to build a routing table, supports a few routing protocols, and forward IP packets at the rate close to that of layer 2 forwarding. Multi-layer switches often support specialized hardware such as application-specific integrated circuit or ASIC. ASIC along with dedicated software data structure can streamline the forwarding of the IP packets independent of the CPU. So these are the business considerations for switch selections. You need to consider the following: the cost, the port density, the power, it should be PoE, reliability, port speed, frame buffers, and scalability. These are the considerations in business considerations for switch selection. Okay, for router hardware, the routers use the network portion of the destination IP address to route packets to the proper destination. Switches are not the only component of the network that come with a variety of features. Your choice of router is another important decision because router play a critical role in networking by connecting home and businesses to the internet, interconnecting multiple sites within an interface network, providing redundant paths, and connecting ISPs on the internet. Routers can also act as a translator between different media types and protocols. The routers use the network portion of the destination IP address to route packets to the proper destination. They select an alternate path if the link goes down. The ability to route efficiently and recover from network link failure is critical to delivering packets to their destination. Routers also serve other beneficial functions as follow. Number one, they provide broadcast containment by limiting broadcast to the local network. They interconnect geographically separated locations. They group users logically by applications or department within the company based on common needs or requiring access to the same resources. So these are the different types of routers, Cisco routers. This is network edge routers, as shown in the figure, enable the network edge to deliver high performance, high secure, and reliable services that unites campus, data center, and branch network. Service provider routers shown in the figure delivers end-to-end scalable solution and subscriber-aware services. Shown are the Cisco Network Convergence System or NCS 6000 series routers. For industrial routers, such as those ones shown in the figure, are designed to provide enterprise class features in rugged and harsh environment. Shown are 1100 series industrial integrated services routers. And the Cisco 900 series, this is a small branch office routers. It combines WAN, switching, security, and advanced connectivity option in compact. The router form factor Cisco ASR 9000 and 1000 series aggregation services routers. These routers provide density and resiliency with programmability for a scalable network edge. Cisco Network Convergence System 5500 series routers. These routers are designed to efficiently scale between large data centers and large enterprise network, web and service provider 1, and aggregation network. This example of form factor. Another form factor is the Cisco 800 Industrial Integrated Services router. This router is compact and designed for harsh environment. That's all for Module 11 of this curriculum. So see you on the next module, which is module 12.